Okay, let's dive right into this. Welcome to The Explainer. Today, we are looking at something incredibly specific, but absolutely vital for your success. We are tackling the Cambridge Computer Science exam strategy, specifically focusing on cracking the stack as an abstract data type, or ADT. Now, whether you are building your foundational knowledge in syllabus 0417, 0478, 0983, 0984, 2210, or you are right here with us deeply analyzing the advanced 9618 AS and A-level curriculum, the strategy we are about to unpack is going to completely change how you approach your papers. Now, we've all seen the archetypal students, right? Think about your own study group. First, there's Alex. Alex is the one who overloads his brain with raw, unfiltered computer science facts. He memorizes the entire textbook, but when he gets into the exam hall, he has absolutely no idea how to actually analyze the data presented on the page. He dumps facts onto the paper and hopes something sticks. And then on the other end of the spectrum, there's Sam. Sam knows the material, but Sam rushes. Sam completely misses the subtle, critical requirements hidden inside the command words of the question, losing massive amounts of marks simply because of poor execution. Today, we are stepping far, far away from both of those flawed approaches. We are adopting what I call a hacker mindset. We aren't going to just memorize. We are going to find the back door into every question. We're going to work smarter, not harder. We are looking directly at the source data from the principal examiner reports, and we are going to crack the system to see exactly what gets the top marks. Let's get started.
15%. I really want that number to sink in for a second. According to our source material, the stack as an abstract data type accounts for approximately 15% of the total marks in Paper 2 of this computer science syllabus. That is a huge chunk of your grade tied up in one very specific, highly targeted topic. It makes the stack ADT the ultimate high-value target for our entire exam strategy. Think about what 15% actually means in the context of your final results. If you can master this one area, you are not just picking up a few stray marks here and there. You are securing a foundational piece of your final grade. You are talking about the difference between missing your university offer and comfortably securing your spot. It is enough to swing you across grade boundaries. So treat this topic with the respect it deserves. It's high stakes, but it's also highly predictable if you know what to look for.
Here is our exact roadmap for today, essentially your hacker's blueprint. Section 1, the logic architecture. Section 2, executing methodology. Section 3, avoiding fatal errors. And Section 4, the evaluator mindset. Let's jump straight in.
Let's start with Section 1, the logic architecture and its core principles. What is really interesting about the Cambridge Assessment Framework is its underlying philosophy. They aren't trying to trick you, but they are filtering you. The source material emphasizes that the academic benchmarks here absolutely require logical, structured reasoning. The examiners are explicitly prioritizing analytical depth over superficial breadth. So what does that actually mean for you? It means they do not just want to see that you know what a stack is on a surface level. They don't just want you to say it's last in, first out and move on. They want to see precise definitions. They want to see causal relationships. They want evidence-based reasoning. They want to see the architecture of your logic written out on the page. Remember Alex? This is exactly where Alex fails. Alex gives superficial breadth by listing 10 random facts about stacks, but zero analytical depth about how the stack actually functions within the constraints of the specific exam question. Don't be like Alex.
And this quote brilliantly illustrates how you demonstrate that required depth. This is a direct quote pulled straight from the principal examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. Think of this as an insider exploit, a backdoor to the A-star. The theoretical architecture of the stack ADT rests heavily on its integration with other syllabus areas. If you can show the examiner how the stack interacts with other elements of computer science, like memory management, recursion, or operating system processes, rather than treating the stack as an isolated concept in a vacuum, you instantly elevate your answer from average to exceptional. The examiners are practically begging you to connect the dots. When you do, you trigger the higher mark bands.
Let's move to Section 2, executing the methodology, or as I like to call it, the exploit. We know the theory, but how do we actually extract the maximum points on exam day? Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's talk execution. We are specifically focusing on what the sources call the method mark strategy. It is absolutely crucial to understand that it's all about how you show your work and the structured process you use to get to the solution. Let's break down exactly how the top students structure their answers to guarantee those marks.
The source data provides a highly specific procedural framework. This is how you systematically process these complex stack ADT problems without getting overwhelmed. Step 1. Deconstruct the question. This means breaking down those tricky command words. If the question says evaluate, you cannot just describe. Sam always messes this up. Sam rushes and describes the stack, getting 0 marks because the command word asked for an evaluation. Step 2. Extract the relevant data. The source specifically highlights that interpreting complex binary representations and extracting the correct parameters from the given scenario is critical here. Step 3. Execute your analysis. This is where you deploy the Peel framework. If you want top marks, you structure your analysis with point, evidence, explanation, and link. Make your point about the stack operation. Provide evidence from the data you extracted. Write out your explanation of the mechanics, like how the top pointer changes. And finally, link it back to the specific context of the question. And step 4, verify your results. Run through the logic of your push or pop operation in your head to ensure it makes sense. This standardized 4-step sequence is the ultimate failsafe.
The most crucial takeaway here is understanding the method marks strategy. Look at this very carefully. Marks are awarded for process, clear working, and correct notation. This is exactly where both of our archetype students fall down. Alex throws a bunch of facts at the page without any logical process. Sam rushes through the math and completely ignores the correct notation. The examiners want to see your analytical process. They want to see your mathematical working and your appropriate format just as much as they want to see the final correct answer. In fact, in many cases, if you get the final answer wrong, but your process and notation were structurally correct, you will still pick up the majority of the marks. Presenting your reasoning with the correct computer science terminology is exactly how you secure every possible method mark along the way.
Now that we have our execution strategy dialed in, we need to talk about defense. We are moving into Section 3, avoiding fatal errors, and patching the bugs in your exam technique. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to Ace the Exams IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into the interactive workshop phase. The source material actually combed through thousands of principal examiner reports to identify exactly where students hemorrhage the most marks. Let's look at the top offenders.
Let's look at the top 3 examiner warnings, and we're going to make this a bit interactive. Challenge 1, data scan. Imagine a complex data table on your screen right now, showing a stack operation. You have 60 seconds to extract the core trend. Go! Okay, time's up. Let's see if you fell into any of these 3 traps. Warning number 1, answers are often far too vague. Examiners are actively looking for specific technical details. They don't want to hear the data goes in. They want to hear the item is pushed onto the stack and the top pointer increments. Warning number 2, missing boundary conditions and edge cases. Did you check the edges in that data scan? In a stack, what happens when it's already full and you try to add an item? That's a stack overflow. What happens when it's empty and you try to remove something? Stack underflow. If you don't explicitly mention these boundary conditions, you lose marks. And warning number 3, lack of specific context. The source calls this out as the ultimate classic mistake. Let's do a deeper dive into this one specifically.
Let's visualize that third mistake. Time for challenge 2, find the flaw. Look at these 2 answers. One is a generic textbook answer, and the other is context-specific. I'll give you 30 seconds to spot exactly which sentence in the generic answer is hemorrhaging marks. Spotted it? The primary examiner alert from our source data is that providing a generic answer, even if it is theoretically 100% true, will lose you points if it is not applied to the scenario. Now for challenge 3, speed writing. You have 30 seconds to rewrite that generic flaw into a perfect Peel paragraph. Go. Okay, here's the takeaway. Always link every single point you make to the specific context given in the question. If they give you a scenario about a printer queue or a specific memory function, your answer must speak directly to that scenario, using the variables and names provided in the text, not just reciting textbook definitions. Context is everything. Which brings us to Section 4, the evaluator's mindset. This right here is the master key. If you want to access the absolute highest grade boundaries, the A and the A-star, you need to engage the higher order assessment objectives. And those objectives require a profound shift in how you think. You have to move from simply solving a problem to effectively evaluating it. The sources refer to this as the deconstruct, solve, evaluate framework. You aren't just a student answering a question anymore. You are a computer scientist evaluating a system.
Notice the specific framework that top-scoring candidates use. They don't just blindly find an answer and stop.
They engage in evaluative thinking. They consider multiple solutions. For example, if asked how to implement a stack, they might discuss using an array versus a linked list. Then, they analyze the trade-offs between those different approaches. What is the impact on memory? What is the impact on processing speed? Next, they explicitly acknowledge the limitations of their chosen method. No system is perfect, and acknowledging that shows massive analytical depth. And above all, they justify their recommendations with solid evidence. When you make a decision in your exam, you need to prove exactly why it's the most logical, structured choice based on the data provided. You have to convince the examiner.
Okay, before we wrap up and reveal the final system, I want to share a fascinating mental palate cleanser directly from the source material. It's called the visual story hack. We know that the abstract nature of a stack ADT can be difficult to retain under pressure. The source suggests encoding these concepts using mental imagery and narrative, rather than relying on raw rote memorization. Imagine the stack of data physically in your mind. Create a vivid story around the elements pushing down and popping off the top. Imagine the pointer physically moving up and down like an elevator. It sounds simple, but it's an incredibly effective way to internalize the logic. This means you aren't fighting your own memory on exam day. You're simply recalling a visual narrative. It's a total game changer for speed and accuracy.
And that brings us to our final blueprint. To fully exploit the exam structure and reach that 100% mark potential on your stack ADT questions, you need 3 rules that guarantee top marks. 1. Command word decoding. 2. The Peel framework application. And 3. A time management matrix to ensure you don't rush like Sam. Combine these, strictly apply the procedural framework to grab every method mark and evaluate your findings with specific context. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.